Unit 6, Right Triangles and Trigonometry, Lesson 1, Geometric Mean in the Pythagorean Theorem. Your two objectives for this lesson are to calculate the geometric mean of a right triangle and to use the Pythagorean Theorem to determine whether a triangle is right, acute, or obtuse. Okay, so let's start off with the geometric mean. The geometric mean between two numbers is the positive square root of their product. So in this case, if we have the two numbers a and b, we could find the geometric mean by setting up a proportion. And I've written the proportion here already for you. A over x equals x over b. Now you might be wondering, how did I know to write it this way? Well, in a previous lesson, you learned that in a proportion, these values are called the means, and these ones are called the extremes. When I'm trying to find the geometric mean, I'm trying to find out what x is. So if I have a and b, you know that I would cross multiply here. So I'd get a times b equals x times x is x squared. And now to get x by itself, I square root both sides. So the square root of a times b is equal to x, and that's what this says up here. So the geometric mean is the positive square root, so square root, there's no negative out here, it's positive, of the product of those two numbers, so a times b. Example 1, find the geometric mean between each pair of numbers. Now, there's two ways I could do this. I could set up a proportion like I just did, and you should do this if it helps you. So I could say 12 over x equals x over 3, and cross multiply to solve for x. And I get 12 times 3, which is 36, equals x squared. Now I'm going to square root both sides, and I get 6 is x. So my geometric mean here is 6. The other way I'll show you on part B, it's the same thing. I'm just not going to set up a proportion here. So I know that I'm going to take the square root of the product here. So let me just find the product. 4 times 8 is 32. The geometric mean is going to be the square root of 32. Now, we have gone over this in previous lessons, but we're going to go over it again now. I'm going to simplify this radical. I'm not going to get a decimal answer. I'm going to factor it to get a simplified version. So 32, I can see right here, is 4 times 8. And before I go any further, I should say I'm doing this because if I did take the square root of 32, I would get a decimal answer. So if I said square root of 32, I get 5.6568, and it just keeps going, and I don't like that ugly decimal. So we're going to factor a little bit more here. Well, 8 I know breaks down into 4 times 2. And I'm going to stop right here because I see I've found a pair of twins. And I can kick drop those twins. So this equals 4 times 4 times 2 under my radical. So square root of 4 times 4 times 2. And remember, when you have twins, you're going to kick one out, drop the other. So we have, instead of square root of 32, 4, because that got kicked out, times the square root of 2. And this is my geometric mean without an ugly decimal. Okay, so the geometric mean in a right triangle. So in this diagram, we have 3 triangles. I'll scroll down in a minute so you can see them. And they're all similar to each other. Okay, so we have triangle ABC. It's the big triangle. And then we have triangle ADB, that's on the left side, and triangle BDC on the right. and all three triangles are similar to each other. An altitude to the hypotenuse of a right triangle forms two right triangles. You know that. That's the definition of what an altitude is. So remember, altitude goes from one vertex to the opposite side, and it makes a right angle with that side. So when that happens, you split your big triangle into two small right triangles. The two right triangles are similar, and each is similar to the original triangle. And you should remember from a minute ago, we had a over x equals x over b. So the mean here repeats, okay? So when we're looking for geometric means, we're looking for a segment that's going to be used when we write our proportion for our similar triangles. It's going to be used in the denominator on the first one and the numerator on the second one. So if we look back at our similarity statement, because this is the same triangle, we have ABC is similar to ADB is similar to BDC. Let's look at the two small triangles first. So here's one and the other. Okay. And I could set up a proportion here. I could say AD in the yellow triangle corresponds to, so AD goes with BD in the green triangle. So this is yellow and this is green. And, well, BD happens to be in the yellow triangle also, so I'm going to put that here. And that's good because I want to have the same value up top over here and down on the bottom over here. So those should be the same. But you can see again that they do share that side. And BD in the yellow, because this is yellow, this is green, BD goes with CD in this triangle. Okay, so this is my first proportion, and that means that the BD is the geometric mean, so I could say the altitude is the geometric mean because remember BD is the altitude between, well, what are AD and CD? I see AD down here, right here, and CD next to it. Those are the two segments that make up the hypotenuse. Okay, but that's only one geometric mean that I've described there. So we need to find another one. Okay, so let me get rid of these marks so that we can look again. And really, again, because we do want, for the geometric mean, we want a repeated side. Let's just look for sides that these triangles share. Okay, so if I look at the big triangle, I can see that it shares side BC with the little triangle. You see that? So right here, they share BC. So I could say, I'm going to do this one in blue, BC and BC, because that's going to repeat. And this is the big triangle. And again, BDC is the green triangle. Okay, so BC in the big triangle goes with DC in the little one. So this is going to be big and this is going to be green. I said DC. And BC in the green triangle goes with AC in the small one. So BC is the geometric mean between the hypotenuse of the large triangle and this portion of the hypotenuse, which is on the small green triangle. Okay, and one more. So I'm going to get rid of this green triangle. There's my X, there it is. Okay, and we're going to do a yellow one. So we're looking for what side does triangle ADB share with the big triangle? Well, it's this one. Okay, so let me do this one in red. And again, ADB is the yellow triangle. Okay, so we're doing big and yellow. So these sides are on the big and the yellow. And we said they both have a B. Okay, so on the big triangle, AB goes with AD on the yellow triangle. And on yellow, AB goes with AC. So again, you can see AB is the geometric mean between the hypotenuse of the large triangle and that portion of the hypotenuse on the small triangle. Okay. Example 3, we want to find x, y, and z, and we're going to use geometric mean in order to do this. Okay, so let me start off. We're going to find x first, and I'm going to highlight the small triangle that x is on. You can see that better. Okay, and you can see that x and the big triangle share this side of 15. So let me set up that proportion. I'm going to have something over 15 equals 15 over something. Okay, and I remember from my last example that the 15 is going to be the geometric mean of the hypotenuse of the large triangle and that portion of the hypotenuse on the small one. And once I have that proportion set up, I'm just going to cross multiply and solve. So I have 15 times 15 equals 25x. 15 times 15 is 225. And when I divide by 25, I get x equals 9. I'm going to set up an answer box over here. X equals 9. Okay, we still need to find y and z. Okay, so y is next. I'm going to erase this yellow and I'm going to highlight the next triangle, and I can see that y is on that triangle, on that portion of the hypotenuse. So this was a 9. Okay, and just like before, I'll do this part in blue for you so it can stay separate. Well, actually, I don't even have to do that. So 25 minus 9, I can see that 9 plus y is going to give me 25. So I just have to subtract that to get y. So y is 16. That was easy. Okay, and now z, we're going to have to use geometric means again to find z. Do this one in green. Okay, so I know that z is going to be my geometric mean because that's the leg that my small triangle shares with my big triangle. So since it's shared, that's the repeater. Okay, and on the small triangle, the portion of the hypotenuse is 16. On the big triangle, the hypotenuse is 25. So this is my proportion. I need to cross multiply to solve this. So I get 16 times 25 is z squared. 16 times 25 is 400. So when I square root both sides, keeping in mind that this is going to be a positive number because it is a distance, it is a length, I get z is 20. Okay, so that's here, and I've solved the problem. Okay, next we have the Pythagorean Theorem. So in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. We've looked at this before. A squared plus b squared equals c squared. C is the hypotenuse, always, so hypotenuse, because it is opposite that right angle. Okay, the converse of the Pythagorean theorem just works in the opposite direction. So, well, kind of. It says if the sum of the squares of the lengths of the two shorter sides equals the square of the lengths of the longest side, or I should say the length of the longest side, then you have a right triangle. So basically, if you can say a squared plus b squared equals c squared, you know it's a right triangle. Other things that you can do with this, so we just said this first part here, if you add up the two smaller legs, a squared and b squared, and you square the third side, a squared plus b squared is greater than c squared, then you have an acute triangle. And if a squared plus b squared is less than c squared, you have an obtuse triangle. So this is pretty useful. Example 4. We have two parts on example 4. We need to find little a. So little a is right here. Well, I know this is a right triangle because I have my box here. So I'm going to say that a squared plus b squared equals c squared. I know that a is just a, plus b is 12, and c is 13, so I just plugged in. 12 squared is 144. 13 squared is 169. Now we're going to subtract 144 from each side. A squared equals 25. To get the a by itself, we need to square root. Remember that square and square root are opposites that undo each other. So a equals 5. If you wanted to check this, you could go back up here, plug in your 5, and put your 12 back in there and see if you get a 169. Okay. Part B, we want to find c now. So this is the hypotenuse. Remember, a squared plus b squared equals c squared. So c is the hypotenuse. So we have 20 squared plus 30 squared equals c squared. Now notice I put 20 in for a. And really, you could have done that either order. It wouldn't make a difference. But right here, since I do have this angle labeled a, the side opposite it is little a. So little a is across from big A. Okay. 20 squared is 400. 30 squared is 900. When I add those together, I get 1300 is c squared. Now I'm going to square root to get c by itself. And if I take the square root of 1300, you can probably see this, that is an irrational number. So I have 36 point some ugly decimal. So I am going to simplify the radical here. We are going to kick drop. So I'm going to start off, I'm going to say 10 times 130. And I know that 130 is 10 times 13. And from here I can stop because I do have a pair of twins. Now, if you wanted to break that down to the bones and get every single digit, that's fine, but I'm going to stop here. So I end up with C, because I took the square root, is the square root of 10 times 10 times 13. Kick a 10, drop a 10, leave a 13. So C is 10 square root 13. And that's my answer. Okay. Example 5, we want to determine whether or not triangle PQR is a right triangle. And I believe this is our last example. Yes, it is. Okay. So I see that 20 is my hypotenuse. So I'm going to check. When I say 10 squared plus 10 times the square root of 3 squared, do I get 20 squared? Okay, let's find out. 10 squared is 100. If I square 10 times the square root of 3, I have to distribute this square to both parts of this. So I'm going to get 10 squared is 100. Square root of 3 squared is 3. So does this equal 20 squared is 400? I get 100 plus 3 times 100 is 300. And this is a 400, which does in fact equal 400. Since those are equal, I'm going to say yes, it is a right triangle. Okay, and that is it for lesson 1.